Welcome back to Maths with Armien. This video here is a continuation of Finance Part 2 of 3, and we're going to look at problems on future and present value annuities. Let's look at the outcomes for this lesson. First of all, we're going to have a brief overview of the concepts and formula of future and present value annuities that was discussed in the previous video. Then we're going to do regular payment calculations, and then calculating the number of payments, and then calculating outstanding balances, calculating final payments, and then as usual with all my videos we have an exercise worksheet. Let's start with a brief overview of the concepts and formulae of future and present value annuities. Let's briefly go over the concepts discussed in the previous video. What is an annuity? Annuity is a series of equal payments made at equal periods of time. Then we have the future value of an annuity. That's the value of the annuity, and here the emphasis is on the end of the term of the annuity. Then we have, for example, like savings and sinking funds. Then we have the present value of the annuity, and the present value is the current value of the equal future annuity payments at the beginning of the term. Right, so the difference here, that's the value at the end, this is the value at the beginning. There are two types of annuities. First of all, we have the ordinary annuity, and this is an annuity where the regular payments, equal payments are made at the end of each payment period. Together with the frequency of the payments must be the same as the frequency of the compounding interest. For example, if you have monthly payments, the compounding should be monthly. If you have annual payments, the compounding should be annually. And the payments must be at the end of each payment period. Annuity due. It's also an annuity, but here the regular payments are made not at the end but at the beginning of each payment period. Right? The frequency of the payments and the frequency of the compounding must also be the same, but the main difference here, this is at the end of each payment period, this is at the beginning of each payment period. Now let's look at the formula we're going to use for future value of an annuity. In the case of an ordinary annuity, that is where payments are at the end of the payment period, this is the formula we will use. And F represents future value, X the regular equal payment amount, I the compound interest rate, and N the number of equal payments. In the case of an annuity due, the payments are the beginning of the payment period. And this is the formula here. And in this case, we have the future value and we just multiply it by 1 plus I. Now let's look at the formula for present value of an ordinary annuity. In the case of an ordinary annuity, that is, payments will be at the end of the payment period, and this is the present value formula. Notice there that we have a negative n. These formulas are on the formula sheet, so you don't need to memorize them, but be careful that you do not copy them down incorrectly. P represents the present value, X the regular equal payment amount, I the compound interest rate, and then N the number of equal payments. Now we're ready to do some calculating, and we're going to start off with calculating the regular payment amount, or the value of X. Let's look at our first example. We have Thandi who plans to go overseas in 5 years' time, and the trip will cost her 30,000. She decided to deposit a regular amount at the end of each month into a savings account. The interest rate is 8% compounded monthly. We'd like to calculate the value of the amount she needs to save monthly. Now, when you read here, you can do some highlighting. So we should be able to find key words here that will indicate whether this is an annuity. What are the key words there? Deposit regular amount at the end of each month, right? So this is definitely an annuity. So it's an ordinary annuity, end of each month. And there it also said it's compounded monthly. So it's definitely an ordinary annuity. Now, does this represent a present or a future value? And there's also a key word here, savings. So we save for when? You save for the future. So this is a future value annuity. Now let's identify the given values. 5 years, that represents the number, the 5, and because it's monthly, it's 5 times 12, which in this case is 60. Then that 30,000, the 30,000 is the future value. 8%, that's the interest rate, but it's compounded monthly, so that's 8% over 12. I suggest that you keep that as 8% over 12 instead of, you could also write it in decimal, but maybe it's much safer just to keep it as 8%. Now, let's look at the solution to this problem. There we've got the question again. So let's see. We agree that this is a future value, so there's our future value formula that we copy. We have identified the 30,000 and the interest rate and the number of payments. Now, what do we have to calculate? The amount she needs to save monthly, the X value is unknown. It's always one of the values here that will be unknown, not more than one. Now let's do the substitution. So there we substituted all these values in this formula. Just be careful of this. Don't do any calculation, just substitute directly. Now, after you substitute, now you try to make X the subject of the formula. It's advisable not to make X the subject of the formula first. Don't memorize any formula. So that will be 30,000, and this 8% over 12, if I transpose it to the other side, instead of dividing by it, we need to multiply by 8%, and that leaves us with the numerator of that fraction there. Now, because I want X, this is X times, and what do we do instead of multiplying? We divide. So the X will be that 30,000 times 8% over 12, and now we divide by this factor here. Then we just copy that down. Now you're ready to calculate. Don't do any calculations, little bit of calculations in between. Just do one calculation. Carefully enter that in the calculator, and we end up with 408 Rand and 29 cents. It's advisable, clear the calculator, retype everything, and then see whether you get the same answer, right? Always double check. There's more than enough time to do that. So your calculating skills are extremely important. Now look at the second example of a regular payment amount calculation. Justin was awarded the study bursary for an amount of 120,000 and was deposited into a savings account. The fixed interest rate of 9.5 compounded quarterly. He'd like to withdraw regular amounts at the end of each quarter for the duration of this 3-year period of study. Calculate the value of the amount you withdraw from the account at the end of each quarter. Now, when we read this, there are some key words here that will indicate whether this is an annuity problem or not. So let's see what the key word is. Withdraw, regular amount, and end of each quarter. End of each quarter, that will be a payment. The withdrawal is at the end, not the beginning. So it's an ordinary annuity, and there's regular amounts there. That makes it an annuity. Now, is this a present or a future value calculation? Let's see, there should be a keyword, bursary. When you get the bursary, now, not in the future. The bursary amount is allocated now, not in the future. So this is a present value. Now let's identify some of the given values. 120,000, that represents the present value. The 9.5, and it's quarterly, so it's 9.5 divided by 4. So it's 9.5% over 4. And then 3 years, so that's 3, and it's quarterly. 3 times 4 is 12. So there we have everything. So it's important here that you always read the question and maybe you can highlight. Another thing here, when you have the calculation, maybe you can keep it as 9.5% instead of converting it to a decimal, right? But if you're good in converting, convert it. Otherwise, maybe it's much safer rather keep it in 9.5%. What if you make a mistake here and you write 0.95? Now let's actually look at the solution of the problem. There we have the question in case we need to refer to that. We already agreed it's a present value, so there's the present value formula correctly copied. We've got the P value and the I value and the N value. And what is unknown? The X value. So we have the formula, so we substitute directly. It's advisable rather to substitute first and then change the subject, not the other way around. It's much better, it's much safer this way. So we want to transpose this 9.5% over 4. So instead of dividing, it will be the 120,000 times 9.5% over 4. Don't calculate it, just write it down in the meantime. And then let's write down what's left on the other side. X times this factor. If we want X, instead of multiplying, we need to divide. So it will be the 120,000 times 9.5% over 4 divided by that, right? So I suggest maybe you rather press the division instead of using that key where you have the one block over the other fraction key there. Rather do a division. It's much better doing it in a straight line there. But be careful of that negative sign. Now let's use the calculator. If it's calculated correctly, this is the answer there. Now my advice is when you have a question like this, write down your answer, clear your calculator, and then type it again, just to see whether you get the same answer, because so easily you could have made a mistake there. So your calculator skills are essential, especially at the end. Calculate, just make one calculation. Don't do little bits and then you carry over, and just do one calculation this way. Now let's proceed with another calculation. In this one here, we're going to calculate the number of regular payments or deposits, or the period of the annuity, right? So we're going to look at calculating the N value. Let's look at our first example on calculating the number of payments. Let's see what we have. Pumeza deposited at the end of each month 10,000 Rand into a savings account, interest rate being 12% per annum compounded monthly, and an investment yield 612,226 Rand and 7 cents. And we have to calculate the number of deposits. So let's see. Is this an annuity? There must be some keywords there. What are the keywords? She deposits at the end of each month, you know, and it's a regular amount. So that definitely is an annuity. And because it's at the end, it's a ordinary annuity. Now, let's see whether it is a future or a present value annuity. And there must be a keyword. And what's the keyword there? That's correct, save. You save for, that's correct, we save for the future. So this is a future value. Let's just identify the values, amounts that are given here. 10,000, what is that 10,000? That is the regular payments. And then 12% compounded monthly, that's the interest rate, and compounded monthly is divided by 12. Maybe this one is easy. We've got 12% over 12 can just be 1%, right? But if it's something else, just leave it as in percentage form there. And then we have 600 monthly, and then we have 612,226 Rand and 7 cents, and that is the future value of an investment. And then we have to calculate the number, and the number there is the unknown. So that's what we have there. On the next slide, we're going to actually do the actual calculation, but it's important here that you read and try to understand what you are doing. You mustn't guess, because if you make a wrong choice here and say this is the present value, everything is going to be wrong. Now let's look at the actual solution. There we have the question again. And we have seen that this is a future value. So there we have the future value formula. Let's identify all the given amounts. That's correct. And we want to find the number of payments. Now, as I said before, always substitute first. Do not change the subject of the formula first. So we substitute correctly, and just make sure you substitute correctly. Now we want to, instead of dividing by 12% over 12, we have to transpose it. That becomes times by 12% over 12. And then we can write down what the remainder of the equation, the numerator part, there. Now remember, we want to focus on n. So we first have to get rid of quite a few things. The 10,000 and the 1 and this here. So let's see. What do we get rid of first? That's right, the 10,000. That is 10,000 times. So we'll have to divide by 10,000. So that will be divided by 10,000 and we write down what is left there. At the same time, we can transpose the negative 1. The negative 1 becomes a plus 1. And then we can see this is what is left there. Now, now we want to find the value of n. So this is an exponent, right? So if I want to find the inverse of that exponent there, we have to use, that's correct, we need logarithms. So n will be equal to a logarithm. So there's the base 1 plus 12% over 12. So the logarithm should also have the same base. You see, there's the same base. And then we just have to find the logarithm of this number. And it's much better writing it in a bracket. Okay? Because all of that's a logarithm of everything. And now we just need to use your calculator. If you have this key there, you can use that. Otherwise, you can type in the logarithm of that divided by the logarithm of the base. If we calculate that carefully, and we get 47999. Now here, we can't have 47,999 payments. We have to round it up, so that will be 48 payments, right? It's more than 47, so it is 48 payments or 48 deposits that we need to make. Now I suggest with this here, write down the answer, but just recalculate it to make sure that you have calculated it correctly, right? There's quite a lot there, so just to make sure there. And there we have 48 deposits, not 47,99, must be a whole number of deposits. Let's look at the second example of calculating the number of payments. Here we have Werner, who purchased a machine for his business at 92,467 Rand and 1 cent, and he made regular payments of 5,000 at the end of every 6 months to settle a bank loan at the interest rate of 10% per annum, and it's compounded semi-annually. Calculate the number of payments he made. Now let's read the question. Now there should always be keywords that indicate to you whether this is an annuity. Do you see the keywords there? Regular payments, right? And he's making at the end of every 6 months, right? So that's definitely an annuity. Because it's the end, it's an ordinary annuity. Now, is this a future value or a present value? Let's see what's the keyword that we see there. There's a bank loan, right? And that loan, you take the loan now, so it's a present value. Let's identify the given values there. We have 92,467 Rand and 1 cent. That is my present value. And then we have the 5,000. That's my regular payments. So that is 5,000. We have 10% and it's semi-annually. Semi-annually means I have to take the 10% and divide it by 2. Then we have the number of payments that is missing. So n equal to, that's the unknown portion there. Always make sure that you read and understand. Make sure that it is in fact a present value. Now let us look at the solution. There we've got the question again. We've agreed that this is a present value. So there's the present value formula, and be sure that you have the present value formula. Let's identify the given values as well. And the unknown is n. So let's substitute. Be careful that you substitute correctly. Always substitute and then change the subject of the formula. Don't go and change the subject of the formula first. Or please don't go and memorize a formula for n. Just use the formula directly from your information sheet. We have to transpose the 10% over 2. That's the first thing. It becomes a common procedure. So we times by 10% over 2. Don't calculate it, just write it down. So then we have the numerator still left. Now we have to transpose the 5,000 Rand. We have to transpose that 1. There's a negative that we have to make provision for. And then we have this base 1 plus 10% over 2. So what do we get rid of first? That's right. Let's transpose the 5,000. Now we can bring over the 1, that becomes a negative 1, which leaves me with a negative. Now let's pause here a little bit. This negative, if I want to get rid of this, what would this negative do with that negative 1? That's correct. Negative will make this a positive, and then I also need to have a negative there. So if this negative 1 is going to be transposed, it will make that a positive, and it will make this a negative. So let's see. To find negative n, I use logarithms like before. So it's negative n, and it's the logarithm. And if this is the base of the exponent, the logarithm has the same base. So there's the base. And then we have to just copy everything down, remembering that that negative made that a positive. So you see that negative becomes a positive, and that positive becomes a negative. Now we're ready to do that in the calculator, right? Just make sure here that should be a positive and that should be a negative. Why? Because it was still this negative that we had to transpose. Now let's get that on the calculator. And if we calculate that, it gives us a negative. This should give you a negative. Now let's be careful here. That negative and this negative will become a positive. So the negative we've sorted out. But how many payments must he make? 52? No, it must make more than 52. Although it's even a small decimal, it is more than. So he has to, and more than 52 means 53 payments. So you always have to round up to the nearest integer, even though, you know, that it's a very small decimal, but it's definitely more than 52. It's going to be 52 of those 5,000 payments and a smaller extra payment in there, which we will discuss with you in some later slides. So be careful there. When you basically, this is quite a long calculation, do it carefully, write down the answer and redo it just to make sure that you have done everything correctly. It's much better pressing a division instead of that fraction key on your calculator. It's much better just saying divided by that instead of, otherwise then do everything rather in one line. Now the next calculation that we do is this idea of calculating an outstanding balance of a loan, and we will briefly discuss the concept of what do we mean by an outstanding balance of a loan. Let us look at the concept of an outstanding balance. To do this, let's just take an example. Now we have Angie who took out a loan for 44,000, and she's taking it out with equal payments that she makes at the end of each month, right? And she's doing it over 5 years, and she pays 1,000 every month at the end of each month. And the interest rate is 12% per annum, and that is also compounded monthly. So we can see that this is an annuity. It's actually an ordinary annuity because payments are made at the end, right? You see, that's quite normal there. And for 5 years and 12, so it's actually she's supposed to make 60 payments. But let's say that after making 30 payments, she would like to settle her loan. And we'd like to know what is the amount that she owes. Now this amount that she owes after having made the 30th payment, that is known as the outstanding balance of the loan. So we're going to look at this and show you how we can go about calculating an outstanding balance. To do this, let's take Angie's situation and let's just tabulate it, go through it step by step and see, right? So she's taking a loan of 44,955 Rand. So, and she's going to pay it at the end of each month, right? So the loan she takes at the beginning, so for 1 month, that loan accumulates interest. So let's see, so that 44,955 after 1 month, it has grown. So there's a growth and it becomes 45,404 and that 55 cents. So that is the growth there. But then at the end of the month, she makes a payment. So they have to take that 1,000 away from that, and this leaves. So this is the balance at the end of her first payment, right? Now, then that balance there for 1 month, it has a growth again. So that grows, and so that 44 grows to this 45. And then at the end, she makes a payment again, and that's the balance after the second. And let's try the third one. So that's the end of the third month. This is what the growth, it has grown to that. Then she makes a payment at the end, and that's the balance. So that's the balance, and we can continue doing this, right? And then if we take the 59th payment, we see that the balance after making the payment of 1,000, the balance is 999 rand and 0.99 cents, and then that grows to 1,000, and then she makes a final payment of 1,000, and her balance is now 0, right? So this is actually what happens if you have that. So we would like to know, in Andy's question, what was the balance after her, let's say, her 40th payment? So it's somewhere here, but just imagine, you can't to do this now until we get to the 40th. Is going to be really time consuming, and so we'll show you a way in which we can calculate any outstanding balance there, right? But this is sometimes in business they use tables like this so they can see exactly what the balance would be. You can set this up in an Excel spreadsheet. It's quite simple. Now let's look at Angie's situation. Just look at the graphical view of the graphical understanding of what's happening there. So if we plot all those, she took out a loan of 44,000, right? You can see, and then she made a payment after 10. That would the balance be, and after the 20th, the balance we'd be able to read off there, and after the 30th, the balance would be there, and after the 15th, or what the balance would be, so. And then when she gets to the after making the 60th payment, you can see her balance is 0. So that's actually, so we can also have done it from a graph and read off there. But you want to know the exact amount, and we're not going to use a graph. Now let's actually look at the outstanding balance idea here. So who are the role players here? There's the bank, right? And there's the customer, Angie. Right? Now the bank, what is the bank? The bank wants interest, and that interest, it's compounded, right? It's a compound growth. The customer again has to make regular monthly payments. Okay, then the bank, that's the growth of the bank's loan. So the growth there, we'll just use our compound formula there. And these are payments, so she's paying this until, so that's all the sum of all her future payments would be. Then we can calculate the future value of all her payments up to a certain point there. Then the outstanding balance is thus the difference between the A and the F. In other words, the growth of the loan minus the future value of all the payments. So that's how we can calculate an outstanding balance there. So an outstanding balance is the difference between the compound growth of the loan amount and the future value of the total payments, and that is the outstanding balance. Let's summarize what we have there. So the outstanding balance is the difference between the compound growth of the loan amount and the future value of the total payments made. That is the outstanding balance. We can write this down in symbolic form. So the outstanding balance after K payments is, this is what the compounded growth of the bank, and this is the future value of all the payments. And there's the formula for compound growth, and there's the formula for future values. Obviously, we'll work this out separately, we'll work that out separately, and then we subtract the two. Okay. So just to get that, A is the compound growth of the loan, P is the present value of the loan, and outstanding balance, F stands for the future value, right? X is the regular payments, and I is the compound interest, and K is the number of equal payments. Let's look at an example now. We have Angie who took out a loan of 44, so we're going to actually calculate everything. And she's making equal payments at the end of each month, right? And the loan is 44,955 rand, and so there's the 44. That's the present value, and the 1,000 rand is the value of the monthly payments. 12% monthly, that's the interest rate, and there are 40 payments, so that we want to find the balance after the 40 payments. We have to find the outstanding balance, and that is how we will find the outstanding balance. We look at the growth, subtract from it the future value of all those payments made. Now let's look at the solution to this problem there. So there we've got the question again. That's the values that are given. And we're going to now find the outstanding balance. So there are two calculations that we have to form, the growth and then the future value, right, of all the payments. So the growth there, let's work it out separately. So we'll use the compound interest formula, growth formula there. We substitute. That's after 40 payments. So it's the 40 for that's the loan amount. The interest rate is 12% over 12, and that's 40. And that gives us 66,931.87. Then we look at the future value. There's the future value formula. We substitute 1,000. That's the payments. It's the same interest rate, 12% over 12. And it's this, you see that 40 must correspond with that 40. And we do this calculation. And that ends up as 48,686 Rand and 37 cents. Now the balance would be the difference. Notice that should always be more than that. So the difference between those two amounts, that is my outstanding balance. The outstanding balance here comes out to 18,245 Rand and 50 cents. Okay, so you're best to do it separately. There is another way to do it, but I prefer this is this is actually clearly in the illustrates the concept of the outstanding balance. We're going to do one more calculation here, and this is the calculation of a final payment, right? As you have seen before that, quite often when you calculate the value of N, then you end up with something like 46,9, then we made it 47. So we want to see what is that last payment, which is not a full payment. Let's consider the concept of a final payment. Right, to do this, let's take an example. We've got Rakesh who takes a loan and he agrees to pay at the end of each month, making a regular payment, and the loan is 44,800 and the regular payments are 1,000. He's going to pay it back over 5 years, and the interest rate is 12% per annum compounded monthly. Actually, the actual payments was not 1,000. He decided, so the actual payments was 996 Rand and 55. So he's actually decided, let's pay a rounded off amount, right? So the final payment will not be the same. If you also refer back, when we calculate the number of payments, quite often when we work out the end, it might end up as, let's say, 47,5. But then we make the payments not 47, but we round it up, it becomes 48. So the last payment is different to the other payments, and we want to find what is that final payment, right? So he actually paid more, so therefore his final payment should be less than the 1,000, and we want to know exactly how much, and so we'd like to determine that final payment, which we're going to do in the next few slides. Let's look at the procedure that we're going to follow. Okay, first of all, we have to find the outstanding balance after the penultimate payment. Now, what do we mean by penultimate? That's the payment just before the last, right? In other words, if he has to make 50 payments, the penultimate payment will be payment number 49. If he has to make 30 payments, the penultimate one would be 29, right? So the payment just before the last. So therefore you can see it's the last one just prior to the last, or the second last payment. Because if we know that balance, then there's only one more payment to be made, and that is the final payment. So the step 2 is, once we've worked out that outstanding balance after the second last payment, then we'll just have to compound it just one for one more month. So just interest for one more month. And that's the procedure. So first of all, how do we go about the outstanding balance? We have to know that method of finding the outstanding balance there. So it's just an extension of an outstanding balance type of question. But here it's the balance, not just any one, it's the one just before the last. So let's consider an example. Let's go back to Rakesh's example there, right? He's got a loan, he pays at the end of each month, right? Let's make regular payments, and the loan is 44,800, and there's 1,000 Rand, 12% for over 5 years, and which is compounded monthly. And we want to calculate his final payment. So we know the loan amount is 44,800. The regular payments is 1,000 Rand. It's supposed to make a total of 65 years times 12 is 60 payments, and the interest rate is 12% per. Now let's just do the solution. Now there we've got the question again, and those are the values that we just identified in the previous slide. So the first step there is to find the outstanding balance. How many payments is he making? 60. So we want to find the penultimate. The penultimate one would be payment number 59, right? So we'll have to work the outstanding balance. Procedure is we have to find the growth for 59 and the future value for 59. So let's just do that. So look at the growth of that 44,800. That's 60 minus 1 is 15. I'm just putting in 1 to show you that's the penultimate. And if we calculate that, that gives us 80,582 Rand and 90 cents. Then we work out the future value up to the 59th, the end of after the 59th payment. There's the formula. And then we put in the 1,000, and if we calculate that, we get the value 79,870. As you can see again, this year is much more than that amount there. So to find the outstanding balance after the 59th payment or the penultimate payment, we subtract those two values. And if we subtract that, we obtained 711 Rand and 20. So that's his balance just before the end of the 59th, after he made the 59th payment there. Now, the final payment would be our step 2. And the final payment here is that amount just needs to have 1 month more of interest, right? So the final payment would be that outstanding balance times 1 more month, 1 plus I. And if we calculate that, the same interest rate, 12% over 12, so his final payment there is 718 Rand and 34 cents, right? Again there, with these calculations, do them more than once just to make sure that you have it correct, and always make sure that this amount here is more than that amount, right? And this amount here will have to be less than that 1,000. And those are the types of examples. In the next video, we're going to do other examples. So we still have to do 2 more types of applications of annuities, and the one is deferred payments, and the other one is sinking funds. Now we come to the most important part of the video. That's the exercise worksheet for you. But before you actually start this, I suggest you go through the slides again, and specifically some of the questions. Try to do it on your own, and then you compare your answer to the given solution there. Don't just rush into this. First, make sure, and it's important, you need to understand the concepts, right? Understand the concept, and then don't just remember solutions there. We've got a question there, and you can see there we must calculate Samuel's monthly. We're not going to, and important, you must read. You see, there's a lot of reading, so I really advise you to highlight the given values, highlight the key words to see whether it's a future or there's always key words in the problem. If I look at this one here again, there's inheritance, that he invests his inheritance, how many withdrawals, so it's, so you must see that amount is the amount that he gets now, so that will be the present value, etc. So please read, highlight all these, like 8,000, 800,000, and 14%, and 10,000, so you don't have to go and read everything a second time. So highlight would really be a good yeah. There we have question 4. There we have question 5, right? Calculate his monthly installment. And here we have question 6. There we have a question here I see on outstanding balance. So you need to know the procedure to follow there. And then here calculate how much money. So we have 8 questions. And here lastly here, as the last question, calculate the value of the last payment, right? How long? So that's the number of. Thank you very much for viewing my video. I suggest that you also go to the other videos on finance, and there's some videos on calculus and on functions. And please subscribe to my channel, Maths with Armien. Thank you very much.